For Descartes' rule, remember, you're finding possible real zeros. That means not complex. You could just graph this and see how many real zeros you have on there. Or you can do Descartes' rule. Here's Descartes' rule. What you do is you have to do two different things. You have to look for possible positive real zeros, and to do the positive real zeros, you just use the function that you're given. And so it's f of x equals 3x to the third minus 5x to the second plus 6x minus 4. And then you also have to find the possible negative real zeros. To find this one, you have to plug in a negative x. And so when I plug in a negative x, it looks like this. Negative x to the third minus 5 negative x squared plus 6 times negative x minus 4. Now plugging in a negative x, let me simplify it now. Negative x raised to the third power would be negative x to the third, so you would get negative 3x to the third. And I'm afraid I'm going to lose people on that one, so I'm going to do this over here. 3 times negative x to the third. This would be 3 times negative x raised to the third power. So that's a 1 right there, so I go 3 times negative 1, and that's what gives me this. Negative 3x to the third. This one right here, what is negative x squared? It's x squared, right? Negative times a negative is a positive, so that's just x squared. And so this stays negative 5x squared. That one doesn't change because of the squared. This one does change. It's positive 6 times a negative 1x, so it's going to be negative 6x, and then you have the minus 4. Alright, so this one is going to give you, or it's going to tell you the possible negative zeros. Alright, so let's look at this one first. Let's find our possible positive zeros. And this is all you have to do. You guys ready? Look at the signs. Whoa. Sorry, almost choked on my tongue there. Look at the signs. This one's a positive 3, and this is a negative 5. Does the sign change? Yes. Okay, so I'm going to say yes right here. Does the sign change from here to here? Yes. Okay, so it's sign change. Does a sign change from here to here? Yes. And since we're at it, since we're checking signs, let's go to the other the negative ones. Does a sign change from here to here? Yes. What? No. Look at it. This is negative and this is negative. Does a sign change from here to here? No, no sign change there either. Does a sign change from here to here?
What do you mean by sign change?
No, like if it goes from positive to negative or negative to positive. Okay, now this one's all no's and this one's all yeses. This is kind of a unique situation. We don't get this very often. Sometimes you have 2 no's and 1 yes or whatever. Now for the positives, now this is for the positives right here, positive real zeros. We have a possible 3 positive real zeros. Because there's 3 yeses. 1, 2, 3. There's 3 sign changes, so that means there's 3 possible positive real zeros. Over here, since they're all no's, then there's no negative real zeros. This doesn't exist. There's no negative real zeros.
What if one of them is yes?
Now, if one of these was a yes, like let's say this one was a yes, because this is a positive 4. Let's just pretend it's a positive 4, so we have a sign change right here, right? So that means there'll be 1 possible, this would change to a 1, 1 possible negative real zero. Does that make sense? Okay, but it's not. It's all no's. Now this is the part I don't like about this Descartes rule, because I'm not going to take the time to prove it to you or show you guys why. You kind of just have to accept this. There's either going to be 3 possible positive real zeros, or there's going to be 1 possible positive real zero. Now, why is it down to 1? How come it skips 2? How come it goes from 3 to 1? And all you need to know is that it always decreases by 2. So, let me show you an example. Go back to this one right here. Let's pretend that there was, I don't know, 7 yeses right here. There's 7 yeses. Okay, and then that means you have 7 possible negative real zeros, or you could have 5, or you would have 3, or you would have 1. It always decreases by 2. Does that make sense? Why? See, you're asking why, and that's the very thing that I told you guys. I'm not happy about this, but I can't tell you why right now because we don't have time to sit here and prove it. Okay, so just to recap, your answer here would be there's either going to be 3 positive real zeros or there's going to be 1 positive real zero, and there's no negative real zeros. That would be your answer. That using Descartes' rule, Descartes just tells you, his rule just tells you how many real zeros there possibly could be. And so, do we have to write that there's 1?
You have to write that there's 3 or 1?
Yeah, you have to write that there's 3 or there's 1. That's the only purpose of this test. And once you get it, it's kind of like, oh, I don't see the mathematical reason for this. But try your there's one of your FRQs that asks you to use this. That might help give you guys reason for this. These are the answers. Either 3 possible real zeros or 1 possible real zero, and there's no negative real zeros. Now, if you actually graph this right here, you'll see that there's no x-intercepts that are real over on the negative side of the graph. On the positive side, there's either going to be 3 x-intercepts or 1 x-intercept.
And you list all of them, so say you had 0.
You don't have to actually list the x-intercepts. You just list the possible, like how many there's going to be.